The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. My name is Dave Bentley, and I would like to welcome you to the IEC National Webinar Series. Today's webinar is titled Replace or Recondition, Evaluating Water-Damaged Electrical Equipment. Please note that we will be recording this session, and it will be available to you on the IEC website under the Training tab and Continuing Education. You are currently joining this webinar via your telephone line and have dialed in using the code provided, or you're listening in using your computer speakers and voice over IP feature. All attendees will be muted for the duration of the call. We encourage you to send in your questions by typing them on the dashboard on the right side of your screen. I will repeat all the questions for our presenter today at the end of the session if time allows. Today's speaker will be Bryan Holland, Southern Region Field Representative from the National Electrical Manufacturers Association. Bryan is an ICC Master Code Professional and currently holds 34 ICC certifications and 23 FEMA certifications. Bryan is a licensed building code administrator, plans examiner, and inspector in the state of Florida. He also serves as a course developer and instructor for the International Association of Electrical Inspectors and Electrical Council of Florida. He is also a principal member of the NFPA 1078 and NFPA 78 technical committees. And with that, I'll turn it over to today's speaker and turn it over to Bryan.
All right, fantastic. Thank you very much. I appreciate that nice warm welcome. It's certainly an honor and privilege for me to be able to present this webinar to you guys today. IEC has been an amazing partner, a coalition partner with NEMA on state code adoption and electrical safety advocacy in general. So again, it's a real privilege to be able to be here today to talk about this very timely subject matter, replace or recondition equipment that's been affected by water. Certainly with this 2017 Atlantic hurricane season, we see the need to have this type of training and understanding of the impacts that water can have on electrical equipment. And believe it or not, this program was actually thought up way back in February. So your education coordinator, Christy Scodera, met with us NEMA field reps in February and said, let's get a 2017 IEC webinar series together. Little did we know back in February that we would have two U.S. mainland falling storms and, of course, Maria impacting two of our territories that would have such devastating effects, including water damage from both rain and flood. So this is a great subject matter to talk about, considering everything that's happened, what we've learned from these most recent storms, and then other flooding events that have occurred in recent history. So again, this being a NEMA IEC joint presentation, but most of the information that you're getting here is from the NEMA member company. So these are the manufacturers of the equipment that do all the R&D, all the certification testing, all the installation instructions. They understand their products better than anybody and know what they can withstand and what they can't. So this is their consensus understanding of what that evaluation should entail, and then what equipment needs to be replaced with no further thought, and those equipment that can be reconditioned with certain considerations. So again, we're concerned with exposure to water primarily, and that source of water can come from a host of different areas or places. So we'll talk about that when we get into it. And again, for the talking points, this is really anybody that's in the supply chain of electrical products, suppliers, installers, inspectors, whatever your background is. I assume most of those of you on the call are electrical contractors, which is great because you're the one that have to be right in the middle of purchasing the products and installing those products. So you have the AHJs on top of you, you have your customers on top of you, and you're trying to get as much information you can. And that's one of NEMA's roles. Certainly one of my roles as a field rep is to provide you guidance and information on how to best serve your customers and get out of trouble with your inspectors. And we're going to outline this. So we're going to outline how NEMA put this document together that is now internationally recognized. It's recognized by FEMA. It's recognized by CRS and ISO, and also through the NFIP. So this is certainly a document that you want to have with you in the event you had a flooding event or some other type of water damage event. to assist you with those evaluations. And we know that the hazards are real, and this comes directly out of the document that it's kind of a misnomer that water and electricity don't mix. That's not exactly true. We have many products that are completely suitable for wet locations, that can withstand moisture, can be completely submerged. So it's just simply understanding the right product for the right location, and when you have products that are not suitable for those environmental conditions, that you properly evaluate those before you re-energize and cause a second catastrophe. And that has been our experience with water damaged electrical equipment, that you have your first disaster, you rush to energize, and then you have a second disaster, which is shock, electrocution, fire, so on and so forth. So we're going to try to prevent that today in the future through this training. And again, it affects its performance. It may operate, and that's great, right? But we know that's a problem with electrical equipment. You may be able to get the equipment to turn back on, but now will it function under all future conditions, both abnormal and normal? And that's where we really see the problems. Will it now perform all of its operational characteristics that were intended when it was originally manufactured? And then last but not least, the source of that water and what contaminants, minerals that might be included in it, how that can just escalate the event, escalate the corrosion, and be problems for you in a more short term. So again, we talked about the hurricane. So what you're seeing there is it's Harvey and Irma. We've got a lot of takeaways from these two storms, and we have a lot of lessons learned, and we're certain this is going to impact our future SOPs on disaster response. We know FEMA and some of the other big insurance agencies are reevaluating how they respond and what their recommendations are afterwards, considering it's been 5 to 10 years since we've had major landfalling storms. But to give you an idea, two different storms completely. You can see Harvey, 50 inches of rain, Irma, not so much. 200,000 flooded structures from Harvey, but 55,000 or so from Irma in the state of Florida. Harvey, being a rain and storm surge event, resulted in about 300,000 power outages. Irma, on the other hand, was 6+ million power outages. So Irma resulted in the second largest power outage in United States history, right after Superstorm Sandy. And you can see what the billions of losses are. Now, those are floating numbers. Don't get too fixated on those. Those are insured losses, so that's certainly not lost economic performance of these states and regions from tourism, employment, uninsured losses, so on and so forth. So this is just what FEMA is reporting right now. So together, 2017 is looking like it's going to be in the top 3 or 4 most costly natural disasters in recorded history. So certainly bad times for the emergency management community, but it presents opportunities to us. What this program is based on now is Superstorm Sandy. That's where we learn the most. Not so much from Katrina, but Superstorm Sandy. And again, you can see it's kind of right in the middle of those two, except way more flooded structures, just as many power outages, again, huge insured losses, and probably the second most costly event after Hurricane Katrina in the Gulf. But what we learned specifically from this event is the hazard of water damaged equipment. And that came from the boardwalk fire. So I'm sure you're all familiar with what happened there. Very infamous event. The New Jersey coast was desperate to get the tourism back, to get businesses back open, to get employees back to work. And unfortunately, it resulted in a rush to re-energize equipment without proper evaluation. And the effects was fire. So a junction box located under the boardwalk filled up with salt water. That salt water started creating corrosion. That corrosion spread to some jointed spliced conductors. That became a high resistance point. That high resistance point ignited the nearby combustible materials, and then the fire spread rapidly through these older structures. And what we learned is that there's this balance between the great pressures the community has to immediately re-energize equipment and get people back to their lives. And that time that's needed, that precious time that's needed to properly evaluate and determine exactly what can be energized and what shouldn't be without being replaced or reconditioned in some fashion. And we'll talk about the NEC and how it's addressing that with future editions of the code, depending on where you're at. You see more pictures of just how devastating it was. So what are those hazards? Clearly, we need to identify the problem. Like, really, what is water doing? Well, certainly corrosion. We know that's a problem. These are metal parts, right? There's a lot of metals, a lot of conductive materials that are used in electrical products. And if they're not intended to get moist or wet, they're going to adversely react to that through oxidation and rusting, and that will limit its performance. Loss of lubrication. Most electrical products are electromechanical, so there are moving parts that need to function and operate. And that loss of lubrication that is internal. You can't re-lubricate. You can't re-lubricate circuit breakers and switches and switchboards. That's done at the factory, and it's supposed to be sealed. But if water enters into those small spaces, it could impact that. Foreign particle obstruction. This can affect those electromechanical operations, switches, springs, internal moving parts of these products that you may not be able to see. On the surface looks great, but all the arc chutes are now stuffed full of debris. And in an overload condition, ground fault, short circuit, some unfortunate event, you may lose its ability to operate properly because of foreign particle. Dielectric insulation breakdown. So we know that insulation may have filler materials that absorb water and transfer that to the conductors, or it may wick up those conductors to the termination points and start corrosion and high resistant connections at those points. Mechanical failure, structural failure, they're similar in that we simply want to make sure that these products operate and that there's no physical parts that fail. So obviously electrical equipment is mounted in enclosures, and those enclosures are mounted to structures. And if any of those components fail, it could result in an electrical hazard that wouldn't have occurred if that failure, that water exposure didn't occur. So those are all great items, but hey, we're electrical professionals, right? We need visuals. This is what we're talking about, right? We're talking about shock and electrocution. We cannot allow that to occur. That's our biggest problem. Followed by fire. And then, of course, we don't need arc flash, arc blast, catastrophic failure of our electrical equipment through unintended rapid disassembly. So we don't want to see that happen. And water, simple exposure to water can cause all these events to take place. So that's what we're really trying to prevent. Maybe those list items on the left are what caused that, but it's the effect that we're trying to prevent. So how we address that is we see the preventative being the most important part of this, right? So we know that we want to do certain things, take certain steps to prevent our equipment from being exposed to water when they're not intended to be. So we're going to talk about some of those measures through FEMA, what the NFIP does, our codes and standards, both the I codes, which is the primary building, fire, energy codes that are adopted in the nation, and of course our beloved National Electrical Code. And then, of course, product safety standards. So we know that through product safety certification, through the NERL program, typically UL standards, we get evaluation for those environmental conditions. And that gives us a lot of insight to what these products are capable of withstanding out in the field. And then we'll transition from that over to the actual evaluating. So we want to talk about identifying the sources of water. It's a step that's missed all the time when you're communicating to the AHJ, to the engineer, to the manufacturer. The first thing they need to know is, great, what was the exposure? Where did that water come from? It changes the entire game, and you'll see why when we get to that slide. How do you conduct the evaluation? So we're going to talk about some talking points, just tips on what does an evaluation mean. Like, define that. Define what evaluation is. The importance of contacting the manufacturer, and we're going to provide you some guidance from NEMA on how to do that. And then we're going to show you the guide. So if you haven't had exposure to the NEMA Evaluating Water Damage Guide, we're going to do a little walkthrough, a quick tutorial of how that document works. And then we'll wrap it up again with just closing some of the concepts related to the code that are being addressed there. Of course, last but not least, you're replacing the equipment or you're reconditioning it. So one of those two events are going to have to take place. And I'm telling you right now, I mean, let's just face it. Default's replace, right? When in doubt, you're going to replace. You cannot be certain even your reconditioning techniques are going to be suitable, and the manufacturer is going to tell you that right off the bat. If in doubt, you're going to want to replace. But we do give you guidelines on what stuff can be reconditioned, how that can be reconditioned, and it's done by qualified persons under the supervision of the manufacturer. You'll likely be able to continue the use of that product indefinitely. So preventative measures, here's one option. This is not Photoshop, this is real. So any of you people that are from the South, like I am, I cover the 11 states of the Southeast. So I know flooding events near and dear to my heart. And this is on the Mississippi River. And believe it or not, this is a FEMA-approved mitigation method for preventing your home be flooded. I guess to each their own, but we're going to talk about what the codes do. We want something more solid than that. So we're going to talk about preventative measures all the way from the national, all the way down through those key legs of the stool that we talked about that our industry sits on. So the guidelines that FEMA provide at the national level, the key one that you want, and these are free, you can download them right now. Just Google search FEMA 348 and you can get that document, and there's an entire section on protecting utilities from flood damage. And typically what happens is that gets incorporated into your state's into your state's flood protection code, either through ordinance at the local level or possibly through your state Department of Emergency Management, one or the other. And then ISO is your community. So some states, some jurisdictions have decided the national guidelines are not enough, and we want to provide additional levels of protection for our citizens, and we're going to do these above code requirements. So be careful, guys. Don't assume that your building code or the national FEMA recommendations are enough for your installations. Make sure you contact your planning and community development departments in your jurisdictions and ensure that they don't have some special requirements related to their CRS that gives them better scores, which reduces your insurance rates in your community. As far as building codes, the go-to is ASCE 24. I wish I could say that one is free. It is not, but that is a document that you should know and have. This is where you get all those prescriptive requirements for protecting electrical equipment from floodwaters and or being resistant by design and construction. So a great document. And then from your building code standpoint, it's the IBC section 612.4 and your IRC R322. Most, again, 50 states and territories adopt a version of the I codes, and most incorporate the flood protection measures one way or the other. So make sure you consult those. But we do have our National Electrical Code, and that's the one we're going to focus on today. And clearly, wet locations are not something that the code-making panels are ignoring. If you take chapters 1 through 4 alone, the term wet location is used 144 times. That's just the first 4 chapters. So clearly, the NEC is responding to the environmental conditions that electrical products may be exposed to. So we'll look at those a little bit as far as preventative goes. And then last but not least, product safety standards. So we know that all your SDOs, right? So your Standards Development Organization, which NEMA is, so NEMA publishes 600 plus internationally recognized product standards, and many of those are incorporated into the UL product standards. But we also have CSA and the other IEC. Unfortunately, that's not you guys, but the IEC that's typically the international or European model for their electrical safety standards. But we know that this is one of the conditions that most electrical products can be tested to, right? So these products use materials in design construction that can withstand a certain amount of moisture. And if installed per those installation instructions per those listing criteria, that product should be durable and withstand that and be resilient to the damage or the effects. So we'll look at those real quickly. We always start at the beginning of the code. So 110.3 is always our important stop. You can never go past 110. It applies to every single installation, regardless of occupancy or use, no matter what kind of construction type. And 110.3a gives us all these drop downs, right? So we have all these different items. And if you look at 1, 7, and 8, you clearly see that you have to take in consideration, where is this product supposed to be used? How is it classified? Are there any other contributing factors that could relate to the safeguarding of persons and property from the use of this product? And if so, what are those? And that has to be taken into consideration. And then our beloved 110.3b, right? So this is the thing that says, hey, there's product markings, there's product labels, there's installation instructions, there's UL guide cards, there's all kinds of documentation that comes out of the product safety standards that tell you how these products are supposed to be installed and used. And it's just as critical, if not more, than the National Electrical Code itself. So if we move through 110, we also see that they talk about, it does make a hint to you. It says, hey, just by the way, there are certain conditions that may be introduced and will cause problems. And it recognizes that those are likely going to be in damp and wet locations. So the code again recognizes in 110.11 that this will likely start to deteriorate the conductors and equipment that are used for the premises wiring system. So it goes on to tell you, let's protect against that. Let's find a way to prevent that from happening. And we see this just as portion as the evaluating. And then informational notes 1 and 2 talk about 300.6, right? And a caution on cleaning agents. So hold that thought for a minute. We're going to get back to that at the very end, and we'll talk about cleaning agents. But it's the one and only time that the NEC addresses it, but we think it needs to be highlighted a little bit more. And then last but not least, we just talked about it. Note 3 and 4 says, don't forget about your building codes and about your enclosures, right? So your building code gives you all kinds of guidance on protection against weather, indoor versus outdoor, wet versus dry. And then our 110.28 is, our NEMA ratings for enclosures, dries to wet to complete submersal. Also, of course, hazardous locations as well. So if you have a classified location, 110.28 gives you that guidance of making sure that the environmental conditions are there. So all kinds of things may be detrimental to the electrical system. We're going to focus on water. If we look at that enclosure types, 110.28, back in 312, when we're talking about conductors themselves or enclosures, you see clearly it identifies what location, what location, what location. Take that into consideration. It changes the product that you're going to use. And there's product standards associated with that. So the correlating with 110.28 is the NEMA 250 standard. So that's where you get your type 1s, your type 3s, your type 3Rs, type 6s, 6P, so on and so forth. And that gets rounded out into UL 50. And UL 50 is actually the product certification standard that they test that to. It tells you how those enclosures are to be manufactured and what the performance criteria is. And same thing with 312 for your cabinets enclosures. We want to ensure that if you're putting dry location only parts, like a panel board bus, right? Or a switchgear or switchboard set, it can be outdoors in a wet location as long as the enclosure, the cabinet itself, has these ratings. And the environmental conditions that are considered hazardous would be 50E or the equivalent IEC 6529 standard. So you know what they look like. I don't need to tell you guys, we're all electrical professionals on the call. You know the difference between a dry location enclosure and a wet location because of the characteristics, usually in a cover, gaskets, bolted systems that prevent the ingress of water to certain levels of degree, right? From just simply being moist to driving rain to rising waters from flood. So pay careful attention to that when you're selecting for installation, especially if you're in a special flood hazard area, which about 80% of the nation is in. When it comes to conductors, we have a bunch of guidance all the way through, again, Chapter 3, moving right into 310. And don't forget about your flexibles. Your cables and cords in the back, they are used primarily for portables, but there is a certain amount of electrical equipment that is not just cord and plug connected, but flexible cord connected through permanent wiring, and they are impacted by their environmental conditions. So again, most of that's going to be product markings, understanding what is that insulation type, and it is impervious to water and moisture. So pay very careful attention. This is the sandy issue. So the sandy issue is the conductors were not capable of being resilient to the saltwater inundation. So be careful about that and make sure your conductors, and we know what those look like. So direct burials, and then also jacketed type raceways or cable assemblies, and then your underground type raceways that are intended to keep the water out in a wet location, direct burials. As far as luminaires, same thing. It'll much like the enclosures. If these are going to be in wet and damp locations, they should be suitable for that, both by certification testing, markings, and then comply with all your installation instructions from the NEC. We have product standards that address that directly. The Supplement A to 1598 is for the marine type luminaires, which are certainly suitable for complete inundation. You know, picture on the bottom left, that's obviously a submersible for swimming pools. So clearly, lighting products can be used underwater. We do it all the time with swimming pools and other bodies of water. But maybe we're not thinking about it along a boardwalk next to a beach or other locations that might be inundated by floodwaters or direct exposure to the rain. So be mindful of that. And then you don't have to do an evaluation. It's already done for you through the product standards. If we get down to the device level, same thing. You're all familiar with this. We know that products, both switches, receptacles, we have very key provisions in the code that identify when, where, and how those products are to be installed. And then we have product standards that are associated with it, and you've seen these. So we have in-use box hoods. We have gasketed covers that keep the moving and exposed parts away from the exposures. The famous WR type receptacles that provide those special extra performance criteria over standard receptacles for exposure to moisture. And if you put the whole system together, the whole system where your wiring method, your enclosures, and your equipment are all suitable for wet location, and they are remarkably resilient to water and moisture. And then when you have an event like a Harvey or an Irma, you're likely to be able to re-energize much quicker than if these products weren't suitable for those conditions to start with. And then you get real extreme, right? So we know things like the oil, gas, marinas, boatyards, these type of products are typically found in those locations and should be considered more often. So, you know, if in doubt, you know, go to these type of products that take it to another level of protection against infiltration of water. And you certainly can always go overboard than going under, that's for sure, when it comes to the code being a minimum standard. All right, so I know I went through that really quick, but we think prevention is important. It's probably more important than being reactive. We want to be proactive. We want to prevent these events from happening, but we have millions of structures and buildings and electrical systems that are in floodplains. We cannot prevent firefighting activities and other types of accidents from occurring that will expose our electrical systems to water. And therefore, we're going to eventually have to evaluate equipment and determine if it needs to be replaced. So the graphic that you're seeing there, I know it's very grainy, but this is from a security camera. That's the subways in New York City. And you can clearly see the water that's coming in, and eventually it does fill right up. It's just topped right out. So that's correct. The exit that you can see that's still illuminated there, you can see a red light over on the left side. All the vending machine kiosks, of course, the electric turnstiles, the doors, all the lighting, everything became submerged. And this occurred not only in the New York City subway system, but many metro systems across the Northeast. And we're seeing the same thing with many basements flooded in downtown Houston, parking garage structures that were flooded, and same thing down in the Keys and along Southwest Florida that were inundated by flood waters from Irma. So certainly it's impossible to mitigate and prevent in an event like this. So all that's left over is to say, okay, let's look at these products. Let's determine what they were intended to be used for. Do they have any construction criteria that make them resilient to water exposure? And if not, I'm likely going to have to replace. Go to my NEMA guide. NEMA guide tells me I can be reconditioned. I'm contacting the manufacturer. Manufacturer gives me those instructions that my qualified staff can now do to put that equipment back into operation. So step one is identifying that water source, right? So we had indicated earlier in the earlier slide that this is one of the most important parts of the step, because look at all these identified sources, right? Rain, flood, firefighter operations, right? So they're coming out on site and you're hosing down the building. That's likely going to enter the building and probably enter luminaire outlets in the ceiling, maybe some fire alarm equipment, smoke alarm equipment, maybe come down the walls into boxes and enclosures for devices and switches, so on and so forth. But also fire sprinklers, water service, sanitary drainage. All of these may introduce water to the system if there's a backup or a break, or maybe some normal operation. Fire sprinklers go off, and you fill up all the luminaires in that area with water. What do we do? Condensation can be a problem. It can be an issue. And then last but not least, other liquid contaminants, which we're not going to spend too much time on. But rainwater's, the key with rainwater is duration, right? So if you're moving products from the supply house to the job site, and you go through, a 2-minute rainstorm, sun shower, and you get a little bit of wet moisture on your products, it's likely that you just dry the products off and you go ahead and continue to install. And that includes even, the most sensitive equipment like NM cable, right? It has an impervious jacket. As long as the conductors themselves didn't get wet or it didn't sit in water, you're likely going to be okay. So again, using some common sense, being practical and reasonable, the duration is going to be a big deal. If that rainwater is a result of a window being blown out from a storm and rainwater infiltrating a receptacle outlet box below the window threshold, that's a totally different situation because of the duration. Floodwater, the big one being fresh versus sea. If you're introducing the mineral content that's with seawater, it can be really corrosive for electrical. But freshwater can be just as bad if that fresh water is maybe from rivers and lakes that are bringing a bunch of debris in with it, right? So what's being left behind, the sediment and the left behind when the water dries or flows back out. And then again, other contaminants, chemicals, oils, dirt, debris, all that stuff that we talked about. Firefighter operations, potential contaminants, again, where are they getting that water? Did they get it from the on-site standpipe, or did they get it from a lake next door where they just dropped the hose in and sucked it out? That may determine what that water's conditions are. Fire sprinklers, again, exposure for operating leaking damage, we talked about. Condensation, again, accumulation of that on the equipment could be a problem over time, right? So that condensation probably won't result in catastrophic failure right now, but what is it doing to those metallic parts through corrosion and oxidation over time? That's going to lead to some type of failure. So preventing that or evaluating equipment that's been exposed to condensation is important. And we talked about this other type of fire suppression, fuel gases, refrigerants, food ingredients, liquids, things of that nature. I saw a fire at a plant in Texas, a Dr. Pepper plant, and Dr. Pepper everywhere, right? So clearly that's going to be a problem different than water. What is left behind? What are the chemicals? What's inside those food ingredients? Not really under the scope of this program, but just keep an open mind about what information you tell the the evaluator or the manufacturer when you're identifying those sources of water. So first step, clearly identify that, document as much as you can, ask as many questions from the user, the building owner, the homeowner, whoever's the impacted person, and try to understand clearly what happened and where that water came from. Step 2, conduct that evaluation, right? So we want to define that. What does that mean, conducting evaluation? And we want to understand what we're talking about there. So we have 3 ideas of that. Visual operations, so that's look for it. You know, it's a feel. You can kind of tell. It doesn't look right. You know it when you see it. Discoloration, signs of rust or oxidation, watermarks, deposits, the chemicals and debris, minerals that aren't supposed to be there, right? So you recognize that growing crystals on the conductors. What's going on there? Material fatigue. You notice all the paper nameplates are melted away and gone. What's happened? Where'd they go? Maybe water came in and left, and the only sign of it is that some materials have been left behind in the signs of rust or oxidation that's occurred, not today, but maybe a month from now. And then that's when your problems start. As far as operational tests, well, we're recommending that this is de-energized, right? So you have an energized, but operate the switch or disconnect, right? You can feel it. Doesn't feel right. It's grainy. You hear like there's something going on. It's not as smooth and clean as when you installed the product new. And again, this requires a qualified person that's familiar with electrical products. You know it when you feel it. Also, things like friction or resistance of, rotational parts. So, spin some rotors, operate electromechanical devices and see, are you hearing squeaks? Are you hearing vibrations? Or any indication that there may be foreign particle or loss of lubrication or corrosion that started. And then same thing with things that are like contact devices, right? So receptacles, knife blades, bus clips, racking breaker systems. If those are abnormally tight or loose, there's something going on with those conductive parts. The parts that have to carry current. And if that's the case, it's likely that some kind of recondition or replacement needs to take place. So it is a visual and it is a feel. So you can do some of these visual operations, and that's what we mean by evaluation. Last but not least, there are some performance tests that you can do. Most of you are probably familiar with like insulation testing, so insulation resistance testing or dielectric absorption testing. So you can determine through known resistances of insulation or how that product is intended during normal operation based on its performance criteria if something else is going on now. And those performance tests will do that. And there's also infrared thermography. So you can do IR imaging and see some hot spots, right? So likely if you have corrosion or if you have problems with the current carrying parts, they're going to be escalated in temperature because of the high resistance connection that's occurring there. And that increased temperature is what's going to result in the failure over time or immediate. So here's a good example, clear visual indication that there's a water problem here, where that water came from, how that water got there, what is left behind, the corrosion, the rusting that takes place. You can clearly see it here. More oxidation than rust, but these clips are going to fail. It's not certain that these products, these fuses are going to operate as intended, that the switch will open and close. Here's another case where all the metal parts look good, but something's going on with those fuses. Obviously the parts are getting moisture at some point, or it's been underwater and it wasn't properly reconditioned or replaced. Here's some debris left over in the bottom of a cabinet, and you clearly see the rust and characteristics of all those terminations. So clearly we're going to have problems, let alone the double taps. So everybody has to point that out. But other than the code compliance issues, this is going to fail. You are not going to be able to carry the capacity of this system under its original load characteristics. Here's a transformer. You can see some debris was left behind, and it's been shifted, right? So it's moved from its original location. So clearly water got under it, floated it, and moved it. What has happened? You probably damaged the conductors in and out, and who knows what's going on inside that enclosure. Here's water At the bottom, you see all the debris that was left over, and there's still water inside the raceway going down underground. Clearly, this needs to be evaluated. Here's another cabinet where you can see all the conductors are laying down in the bottom of the cabinet. Large amounts of rust. This didn't happen overnight, right? So some point, this is either condensation or water got in here, and it's taken this long for it to show up as rust of this nature. This needs to be evaluated. What is the impact of those conductors, and what is happening to the conductive parts on the panel board and the circuit breakers above, or the terminations of the conductors themselves? Here's electronics, so you can clearly see, fire alarm control panel, smoke alarm, CO alarms, strobes. All these, typically electronics are not resistant to water, and you're likely going to have short circuits and printed board errors because of all the corrosion that's left behind. So it's not likely that you're going to do reconditioning on this type of product. So step three is that, and most important part is contacting the manufacturer, because you've just got all the information you need through step 1 and 2. So contact that original manufacturer. They know about their products better than anybody. Have that information in step 1 and 2. Document as much as you can, right? Get as much nameplate data, product labels, the original installation instructions. Take photos, take video if you need to. You may get an on-site visit request. So depending on the scale and scope of the disaster, depending on the equipment itself, they may need to have somebody come out and actually put their eyes on it themselves. So don't be surprised if that happens. And again, they're going to tell you, if you try to recondition without their guidance, you're going to have problems. It may result in additional hazards. You could violate warranties, guarantees, all kinds of issues, legal or technical otherwise. So be careful about that. And we give you some guidance on that. So here's the NEMA webpage, right? So you go to NEMA.org, right? Real simple, just Google NEMA or Google NEMA.org. This is what our homepage looks like. And what I'm going to ask you to do is click on About Us, right? So you click on About Us. That's going to bring up this page that says what NEMA is all about, who we are. But what I'm going to have you do is click on the drop-down box there, NEMA Members. When you click on NEMA Members, it's going to take you to a page that has alphabetically all our members, and I'll just pick the first letter A, and then you get a drop-down of all the A's. I just did a snippet of the first couple, and you can see I've clicked on ABB, and then it brings up who ABB is and how you can get a hold of them. So you clearly can get some phone numbers, you can get their affiliate companies. This will eventually get you to all the other ABB companies, like maybe Baldor Motor or TNB, and so on and so forth. But in any case, that contact information is there. In the event you can't figure it out, the product markings have worn away, it's not clear, there may be some kind of indicator on there that you don't know about, but the manufacturers do. You can contact us field reps, and what us field reps do is we get it to our member sections, and then they look at the product and they say, yeah, well, we figured out that's ours, and then we'll put you in contact with this. So we are your connection point out in the field between the NEMA members and what you're dealing with out there. So step 4 is, again, looking now at the damage guidelines and figuring out how to use them. So there's really only 4 parts to it. Real simple document. You download this for free. We even have it in Spanish translation. This is the 4 points that tell you how this document works and what it looks like. Here's the 8 product category sections that are within the document. So these are similar enough to where the manufacturer of these products feel that they can fall into the same category of replace or recondition, based on some additional guidance criteria that's included in there. And then we have the catch-all at the bottom for maybe some special stuff. And this is open right now, so this document is actually being re-reviewed for additional criteria. And for example, the EVSE market, electric vehicle supply equipment, is going to be putting their own guidance information in there for charging stations. So here's what it looks like. So just to give you an idea, I brought up this electric distribution equipment section, and if we take busways, right? So here's 2 identified busway products, Mylar and powder coated. So notice Mylar, replace. Busway, powder coated, reconditioned. may be reconditioned. You're going to contact the manufacturer, and if there's additional guidance criteria that NEMA can provide you, we'll put it over here in the notes. So there's NEMA BU 1.1, and this is going to be an installation and maintenance guideline for busways. Again, you can download that for free, and it gives you some key criteria on how to install and maintain these systems and evaluate water damage depending on the product type. If we look like another common product, wire cable, flexible cords, you can see NM cable. Guess what? You're replacing it. It's exposed to water. Sorry, it's dry location only. Too many problems with NM cable that gets wet. However, suitable for wet location, it might be able to be reconditioned. There may be a cleaning and drying process that the manufacturer can provide to you. And sometimes they'll provide some equipment guidance over here instead of the right side. And in this particular case, it says, assuming the conductors didn't get wet. So there might be some guidance to cut back into the insulation and re-terminate. And then you're good to go, assuming it's a suitable location. And if we look like maybe another way to look at this table is like if we take, for example, cable tray, it talks about a section. So it's going to refer you to a section. There'll be a narrative. So everywhere you see in the document where it says refer to 4.8 or 1.2, that's going to take you to the back of the document where it's going to give you a narrative. And that narrative provides you a better understanding of what can be done with cable tray and gives you some of that evaluation characteristics. So all the 8 sections provide a narrative later in the document in part 4, chapter 4. Step 5, wrapping it up, is the actual replacement. So it's the actual process of replacing or reconditioning that electrical equipment. You've done step 1, you've done step 2, you contact the manufacturer, they've told you what you can and can't do. You refer to the guidance document to determine what can be replaced or reconditioned, and now you're trying to do it. First and foremost, it has to be a qualified person, right? So we clearly want to make sure that you're licensed, insured. Watch out for your local laws for permitting and inspections, right? Every single state and local jurisdiction has their own rules on that. So don't assume that I'm simply going in and evaluating this equipment, maybe replace a couple circuit breakers, and I'm going to be out of there. Talk to your local HJ. Make sure you have an understanding of what they expect from you, and get permits and inspections when required, even if it's inconvenient to you. So we talked about this earlier. Real important. This is what it says in the code. A lot of these products will say on it, perfect for electrical, right? They're even named electrical cleaner. Well, no, bad news. Just stay away from it, right? This can actually cause more problems and do cause more problems in most cases. So be very careful about going out and selecting your own chemical products and trying to clean electrical equipment that's been exposed to water. The manufacturer, again, will provide that guidance and tell you. And most of the time, if it's a simple clean and dry, it's going to be a very mild soap, heavy on the clean, pure water, mild on the soap, and it's dabbing and removing the materials away. It's not an aggressive type cleaning where you're using wire brushes and all kinds of craziness. You're going to remove too much material and change the characteristics of those metal parts or how they're intended to operate. So be careful, contact the manufacturer. They'll give you that guidance on that. So the NEC, I promised I'd come back to the NEC again at the end here. And this talks about something new for you 2017, guys. I know we're only about 14 states as of October 1st that are on the 2017 NEC. So there's a very good chance that you're on earlier editions. So stay tuned. When you do adopt the 2017 NEC, and many states are in that process, this is a new requirement that if it is indeed reconditioned, whether you do it or you hire a third party or the manufacturer comes in and does it for you, there's going to be some marking requirements in 11021A, Part 2, that gives you some specific requirements for that equipment that's been reconditioned, including some identification and dating on that, and also some markings that say, hey, I've been reconditioned. I am not a new certified product that left the factory with a label from a nerdle. I am now reconditioned, and this is how I got reconditioned, who reconditioned it, and the date it happened. So that's going to help out the user, some future maintenance or electrical contractor, and of course the AHJ as well. And then there are some industrial standard notes down in the informational note. It clearly lets you know that there are product standards. There's organizations like Pearl and others that have complete reconditioning programs. UL has reconditioning programs for certain types of electrical equipment, like motor rewinds, right? Or transformer rewinds. Those are common field practices that is now technically considered reconditioned. And for you that are really up on the code, go ahead and look at some of the PIs that were submitted to the 2020. We're going to see more action on this section 11021. So we're going to likely see an expansion of the code recognizing that there's reconditioned, refurbished, remanufactured electrical products out there in the market, and they're being used. And when you have 1 million structures flooded in 1 year between 4 states and 2 territories, you're likely to see some of those products end up on Craigslist and eBay or on the secondary market, and you may be asked to install that stuff. So having these markings and some of that criteria will only help you understand what you're getting in bed with. So some additional NEMA guidance, just want to direct you to, we have a storm reconstruction toolkit, completely free for you to go on. You go to our webpage. Of course, we have the evaluating documents. We have a third one in development right now. It's for earthquakes, evaluating earthquake damaged equipment. But if you go onto the NEMA.org website, put in storm reconstruction, there's a toolbar at the top. You have all this guidance information. You click on any of these, it takes you to a host of information, as much guidance that we can provide to you. That's what NEMA does. We are an information clearinghouse. We want to be a resource for you to help you do your jobs, all for free, no questions asked. This is our field rep program. I'm your relationship to those manufacturers. And you can see from my particular area, I cover in South, but my 3 compatriots, this is their contact information, how to get a hold of them. We are happy to assist you with not only this, anytime you run into an issue in the field with an electrical product, whether it's evaluating it for water damage, code compliance, product standard compliance, whatever it is, please don't hesitate to reach out. We're happy to provide you that guidance information or find the right people to do it. We've tried to develop as many relationships as we can in our states. So I'd be happy to hear from you if you happen to be in one of my states, and perhaps I'll see you at future events. Our other partner association I'd like to direct you to, this is more for the consumer. This is really cool stuff to hand out to your customers, whether they're building owners or homeowners. ESFI.org/disaster safety. They put out all these really cool infographics that provide all kinds of neat information about electrical safety, right? Nothing to sell you. This is pure information to keep customers safe from shock, electrocution, fire. A huge resource, ESFI. And IEC is a partner with ESFI as well. So this is your organization just as much as it is NEMA's. So with that, I think we can wrap it up. Went a little longer than I was hoping to. I know Chrissy said 45 minutes, but you know, being a code guy, we can be long-winded. But if there's any questions, any comments, any issues that you guys are seeing out there in the field, please feel free to contact me. I believe this program will be made available to you on IEC's website for future use in the recording as well. But if there's anything that I didn't cover, you want to talk about what you're experiencing in Texas, Florida, anywhere else, please let me know, and I'm happy to assist you. So with that, I'll turn it back over to our host, and I thank you for your time.
Thank you, Brian. That was some great information for our attendees today. And yes, it will be available on our website as an archived webinar, the slides and the audio presentation today. This will conclude today's webinar. Please do not forget to complete our quick 3-question survey that we will email out to you probably tomorrow. Also make plans to register for our next webinar, Changing Demographics in the Workforce, Part 1, which will be on November the 15th. You can see a full list of upcoming webinars on IEC's website. Thank you again for attending today.